going to be a +1. So Na 1 plus in both of them. Awesome. And then one of them is with a polyatomic ion, hydroxide, which is OH. Type into the chat, what is the charge of OH? Nice. Beautiful. OH, 1 negative. And then the other one is with oxygen. And oxygen's oxidation number, there's like a couple of rules with it. It's almost always 1 charge, unless it's a peroxide, in which case it's a different charge. But this is not a peroxide. It's not like H2O2 or anything like that. So type into the chat, what is the charge of oxygen? Nice. Charge or oxidation number of oxygen is a 2. Please type into the chat, what is the overall charge of a compound? The overall charge of a compound. Nice. Yes. Beautiful. It should be 0. Perfect. Thank you, guys. So it should be 0. So our Na and our OH, 1 and 1, that's easy. We're just going to leave it as NaOH. And that could either be in a crystalline form. That's generally how we get it. So we get in our deliveries a big container that looks like a big pill bottle, like a vitamin bottle, that has little pellets of these little crystalline NaOHs. And we keep it in some place super dry, and we often have one of those little dry packs in them because it easily absorbs the water from around it to become aqueous. So not knowing here whether or not what we're using in, let's pretend this is an actual lab, we could either say solid or aqueous, just because it absorbs water from around it so easily. Let's think back to solubility rules. Wow, that was a long time ago. Solubility rules. There are a few things that are always going to be soluble. What would I put in the little brackets behind the thing if it's soluble? Would it be solid, liquid, gas, or aqueous? Good, I'm getting some direct messages here that are good. Maybe those direct messages could send to everybody because they're all good so far. Share your knowledge. Awesome. Beautiful. Aqueous or AQ, exactly. So soluble means that we are aqueous. Or AQ. Perfect. So there were certain rules, right? Certain things that are never going to dissolve when they're in water. Other things that are always going to dissolve when they're in water. And then other ones that it depends on what they're bonded to as to whether they're going to dissolve completely, partially, or not at all. Sodium is one of those ones that is always going to give us some soluble things. So again, if you had said that NaOH was aqueous, that would have been a good answer as well. Good answer as well. Okay. So next we've got, we'll do our other reactant in our second problem. How many sodiums do I have to cancel out with the oxygen's charge? Good, good, good. Awesome. Beautiful. Absolutely. I need 2 because if my compound's going to be 0 overall, I need to have 2 of those positive ones to cancel out with the -2 of the oxygen. Perfect. Na2O. And this is the same deal. We could say that it's solid, or we could know that it's something that's going to be soluble in water. And since the sulfuric acid is aqueous already, that might be too. So either one of those would be an accurate way of writing this. Okay. Next up, we're going to form some products. And what's going on again is a switch of the cations. So just like we've seen the last couple days, that's the main thing that's been going on, right? So the cations, those positively charged ions, are going to switch with each other. They're going to do a little switcheroo. So we have H, which you told me is a 1+, reacting with OH, that's a 1-. How would I normally write that? Yeah, it's H2O or water. Perfect. Thank you guys. H2O. In the chat, let's get a few more voices out there in the chat. What would be the state of water at room temperature? Because this is going to occur at room temperature or slightly above, because this is going to be an exothermic reaction. Good, beautiful. It is a liquid. Perfect. Okay, we see the same thing happening down here. I have H1+. This time I have O2-. So what's the product here? Nice, exactly. It's H2O, it's water again. And so that's also going to be a liquid at room temperature. So our general thing that we're seeing here, like we had general things for when it's with a carbonate, it's going to form CO2, water, and a salt. We had a general thing when it's with a metal. We said that it's forming H2 gas, which we said was flammable, and it's going to produce a salt. Same sort of thing is here. Oh, that's funny. We're having some technical issues. Just keep trying. Just keep trying. With these, anytime we have an acid, so acid plus either a hydroxide or an oxide, hydroxide or an oxide, we are going to form water. That's our given. And let's figure out the last part of this now. So when I do this switch between the cations, I have as my second product Na, which you told me was a 1+, and then SO4. Type into the chat, what is that charge of SO4? Nice. Yeah, it's a 2-. 2-. So how many sodiums do I need to cancel out the charge of the sulfate? Perfect. It's going to need 2. Beautiful. So we're going to have here Na2SO4. Again, one of those general solubility rules is that anything with sodium is going to be aqueous. And since it's in water, we know that for sure here. Since we know it's in water, that means that we can just put an AQ behind it. We know it's in water, we know it's soluble, so we know it's going to be AQ. Okay, my other product is going to be Na, which is that 1+, and then SO4, 2- again. We get the same salt. Na2SO4, aqueous. U2SO4 aqueous. They form the same thing. Even though we've got some different reactants, they form the same thing. So many tech issues going on right now. I'm sorry, guys. Thanks for trying to plug along and keep trying, and thank you. So I saw it in the chat. These are salts, water and a salt. So anytime I have an acid with a hydroxide or an oxide, we're going to form water and a salt. And salt, I don't know if you guys had a chance to talk about it last year, what that definition is. Salt really is just an ionic compound. So that means big electronegativity differences. Big electronegativity differences formed in an acid reaction. That's our definition for a salt. So we found in every single one of these acid reactions that a salt was formed. That's a good thing to remember. So in all of these, salts are formed. In every single one of them. Awesome. There's two great questions that came to me. One is about balancing, because we see right off the bat that these equations, at least one of them, are not balanced. So we need to balance them in order to have the correct number of each element on each side. So that's one thing I want you to do, is balance those out. And then the other question I got is, can salts be harmful to the environment? And it depends on the salt. Absolutely. Most are, actually, and it depends on what their cation and anion are. That will tell us just how dangerous it is to the environment or to us in general. You guys might have done a flame salt lab last year where you went around with these little black things, looking through them to see what was happening with flames and the color of flames as you put different salts in them. Did anybody do that in your classes? Okay, couple, awesome, thank you. So there were a couple that, there's some good questions. There were a couple that were done hopefully in the fume hood because they were so dangerous, like cobalt chloride, CoCl2. That would have been done in the fume hood and not by you guys individually, because it's so dangerous to your health. It even destroys red blood cells. So if you've been inhaling it or letting it get through your skin, or you start eating cobalt chloride, I don't know why you would do that. It actually destroys your red blood cells. It makes a really pretty flame color. It's like a magenta and kind of sparkly, but it destroys your red blood cells. So yes, a lot of salts are really bad for us, actually. And then a great question about the IA in general. So are all salts the same for hazardous materials? They're all going to have their individual safety information, so you'll want to look them up on Flynn Science. And I'm seeing some people popping into the chat how to balance them. Let's see if we can get a few more in here. Awesome. Ooh, another good question. I love questions. How do you measure solubility is a good question. I would say the easiest way to measure the solubility indirectly, which would be the most fun way to do it, would be to take the same mass of, or moles, same moles of the salt with different trials and put them into solution and see how that changes the conductivity of the solution. That's a great question. Nice. Awesome. So I'm seeing a bunch of people identifying that this bottom equation is already balanced. Ooh, everything's popping up at the same time. Why are you doing that? Hello. Delete. There we go. Already balanced. And I'm seeing a couple of different things for the top one. I'm going to wait a few more seconds, see if we can get any more. I'm seeing a lot of 1, so we wouldn't have to write anything there, but 1, 2, 2, and 1. I saw a couple that had